Hello and welcome everybody to our IFE Australia Ignite series of webinars sponsored by Zurich Resilience Solutions. Today's webinar is being co-hosted by the wonderful team here at FPA Australia as we aim to bring together fire engineers, firefighting personnel and the wider fire safety community to discuss important subjects and very hot topics such as the firebolts. Excuse my pun. I am Fiona Perrin, one of the board directors with the IFE Australia branch, and I have the honour of chairing today's panel discussion. I work as a senior risk engineer with Zurich Resilience Solutions, where my primary role is to help our customers with their property protection. Given that these firebolts are a life safety concern, I'm one of the few people on this call without any direct stake in this matter. As such, I will strive to remain as impartial as I can and to facilitate a balanced and productive debate on this important subject. I'm sure you've all seen the chatter on LinkedIn and in many of the fire engineering circles about these fire activating retaining devices. This session is designed to help all corners of the industry understand the facts, issues, and concerns. We're not expecting to solve all of these issues today, but we are hoping to do is to shed some light on what is often a misunderstood topic. Before we start, I would like to hand over to our esteemed President, Mr. Ryan Cleggett, to do the acknowledgement to country and the official welcome.
Good afternoon, and thank you for joining us this afternoon. My name is Ryan Cleggett. I'm the President of the Australian branch of the Institution of Fire Engineers, and I'm very excited that the IFE has been able to bring this webinar to you, supported by Zurich Resilience Solutions, and this time partnered with the Fire Protection Association of Australia. This is a very important topic which does require the attention that it is gathering. I'd also like to acknowledge the traditional custodians of the lands that we're all calling in from. We have people dialing into this webinar from all around the nation and internationally. I'm coming from Gadigal land, and I'd like to acknowledge the association and the continued link to the lands from elders past and present. I'd also ask you, while you're a part of this webinar and while you're considering the different positions that are presented, to cast some thought to what our role is in the industry and to the people who are most affected by the decisions that we make. Most likely, all of us on this call won't be requiring a passive fire protection solution to protect us in a fire event. But the people who do require that need us to work together to get the best outcomes for them when those events occur around them. So I'm very excited and thankful for the partnerships and the support of FPA and Zurich Resilience Solutions so that IFE Australia could help bring this together and bring some of the key partners in both fire operations, fire engineering and the fire industry. And I hope you enjoy the content.
Thanks, Ryan, for that lovely introduction. And I'd like to echo Ryan's thanks to all the teams for making this event happen. Before I introduce the speakers, flick to the next slide, I'd like to cover off just a few housekeeping items. So we've got an amazingly big group today. We've had almost 500 people registered, and we've had a huge number of questions already come through for our panel during the registration process. I'm going to try and get through as many of these as possible, but please be patient with us. I will be taking more questions at the end of the session through the Q&A function on your screen. Just so you know, this session is being recorded, and this session will be made available on both the IFE Australia website and the FPA Australia's website in due course. So keep an eye out on our socials for more information of when that happens. Ooh. Just so you know, the IFE and the FPA take no responsibility as to what is covered in today's session. The varying views of our panellists today do not necessarily reflect that of the IFEs. It brings me great pleasure to now be able to introduce to you our esteemed panel of experts today. I have Mr. Simon Rickard, the National Technical Manager at FPA Australia. He brings over 35 years of experience in the fire protection industry. He plays a pivotal role in shaping the association's strategic policies and technical responses. Simon's extensive experience encompasses technical expertise, operational management, and business acumen, making him a key figure in the industry. I'm also joined by Chief Superintendent Stephen Hayes. He is a fire and rescue professional with 35 years of operational experience. As the Assistant Director of Fire Safety at Fire and Rescue New South Wales, he oversees a team providing specialist advice, risk management, and compliance oversight. Committed to firefighter and public safety, his team offers technical advice, assessments, consultancy, and guidance to regulatory authorities. Through audits, training, and policy development, they enhance firefighter protection, injury prevention, and public safety. And then we have Mr. Stephen Kipp, Director of Skip Consulting since 2007. He brings extensive experience in engineering and regulatory consultancy. He has held senior roles at Warrington Fire Research, BRANZ, and was Deputy Building Commissioner in Victoria, Australia. Stephen is skilled in government research design, risk assessment, emergency services, and training delivery. He holds a Masters of Fire Engineering, Masters of Engineering in Fire Safety, from Victoria University. And then, last but not least, Mr. Aaron Nicholson brings over 20 years of fire engineering design experience across various sectors. He's been deeply involved in addressing the combustible cladding crisis in Australia, serving as an expert witness and conducting audits, inspections, risk assessments, and rectification work. Aaron has also worked in the UK and New Zealand and frequently publishes articles on fire engineering issues on LinkedIn. Wonderful. And thank you guys for joining us today. I'm going to kick off today's discussion by throwing a question to Aaron first, as I know you've written about this on LinkedIn. Aaron, can you tell me a little bit more about what firebolts actually are and when they're used?
Yeah, thanks, Fiona. Good afternoon, everyone. I put an image of the firebolt on the screen there, and I'll talk you through it from left to right, and we'll go through where we typically see them. So on the left, we've got like a plastic plug that sits inside the frame, and then everything on the right, so the T-shaped cylinder all the way across to the end cap on the right, that all sits within the leaf of the door itself. And everything fits inside, everything on the right of that screen fits inside that T-shaped cylinder. So you can see there's nothing electronic, there's nothing magnetic, it's all kind of spring forced, and it's just that bolt goes inside the T. Inside the T at the end there, which you can't see, is just another plastic plug. So that's what stops the bolt from coming through initially. So they're fire bolts or fire activated bolts. They're a purely mechanical device. They're used to secure the door leaf to the frame, and they help in maintaining the integrity of the door set, preventing the door leaf from warping or twisting during the fire test conditions. And obviously they do that when they reach a certain temperature. Plastic plugs melt effectively, and then the bolt fires across. They can't be activated manually, and there's no specific requirement or standard dictating what temperature they activate at. I guess the manufacturers try and do it to whatever temperature they need in order to achieve the performance that they're testing for. And the actual activation temperature in a building is going to vary based on the specific device used, the location within the door, the materials used in the rest of the door set, and the temperatures seen during the fire. Okay,
sorry, we're both going too fast there. Sorry, Aaron.
That's okay. On the left there, we have some kind of mounting details, and they're, you know, from a manual, if you like, that shows you exactly what they look like. On the right is a markup of some common firebolt locations in a single leaf door set. So you can see that they are at the top of the door, at the upper kind of third of the door, and they're also on the side that doesn't have the hinge. So if you think about the door set being held in that frame, the hinge is also doing some holding on that top left side. So you don't really need a firebolt on that side. The reason we see them there is, as I said, they're subject to furnace tests, and the doors warp and they open, and they tend to do that at the top and on the opposite side from the hinge there. So these firebolts activate during the test, and their aim is to prevent these gaps from opening up.
So am I right in saying that these firebolts are there basically to help the fire door do its job?
That's right. Yeah, well, in terms of achieving the FRL when it needs to, yes.
Okay. So Aaron, what does the National Construction Code 2022 say about these firebolts then?
No problem. So in the NCC, there's a couple of key kind of references of Australian standards. The first one, AS 1530 2014, and that's part 4, which is the fire resistance test for elements of construction. The second one is AS 1905 part 1 2015, which is about the kind of requirements for construction and installation of the fire resistant door sets. So 1530 part 4 is more about what FRL do they achieve, and the test that they need to go through to achieve to actually demonstrate that. That's where the firebolts are used. And then 1905 part 1 2015 is the installation of door sets of varying FRLs in the building, if you like. So neither 1530 part 4 or 1905 part 1 directly reference firebolts. They don't use that term, though you could say that they're considered door hardware. And if you consider them door hardware, then door hardware is the term that's used throughout the standards. And that's a general term to cover anything that is fixed to or in the door sets. So hinges, handles, firebolts potentially, and everything like that.
Okay, that's interesting. I mean, I spent nearly 20 years working abroad, and I've not come across firebolts anywhere other than here. So whether it's the UK or, you know, across Europe, can you tell me a little bit more about where these actually originate from and why they are here?
Yeah. I've been gone from the UK a long time, despite my accent, so I don't recall ever hearing about them in the UK. Somebody else might be able to give us comment on whether they did come across them or not. Certainly, we're aware that firebolts, and I don't know whether they look similar to the one that we showed at the start, are used in the States, and you know, there's a lot of references that people are bringing up about how the States use them. I think the way that they came about over here is that there's a standard change, as in an Australian standard change in the NCC 2022. So previous to that, we had AS 15 part 4 2005 was the reference document. Now we've got AS 1530 part 4 2014, which is the latest edition. And I guess where it originates is the use of this cotton pad during the fire test. So I've thrown a photo up there. The pole that the person is holding, at the very top of that, there's a white square. That white square is actually a cotton pad held in like a cage. And they kind of move this around the door to pick up hot gases and potentially flame coming through that door, and use it as a failure mechanism, or a point at which certain elements of the test can be deemed to have failed. And the main difference between the 2005 edition and 2014 edition is an interpretation of the cutoff for using that cotton pad. So the 2005 edition, it was interpreted as the cotton pad, and I'm going to read this slightly because I want to make sure I get it right. The cotton pad application was for the determination of integrity, and that ceased at insulation failure. So when insulation failed, the cotton pad was no longer to be used for the determination of integrity. Okay, and insulation failure is when the average temperature on the unexposed face, which is the side that the person's on the photo, exceeds the initial, which is usually room temperature, by more than 140 Kelvin, or when any location on the unexposed face exceeds the initial room temperature by more than 180 Kelvin. So we're looking for hotspots effectively. At this point, insulation failure is noted in minutes, and the cotton pad would have ceased to have been used for the determination of integrity performance. And integrity instead would have been determined by gap gauges or simply by observation of sustained flaming. Obviously, observation of sustained flaming, you would think it would be obvious, but maybe you would miss bits. You know, it's slightly subjective when you leave it down to the individual. And therefore, it's possible that small areas that would ignite the cotton pad, if it was being used, might be missed visually. We don't know, and maybe they wouldn't fail by gap gauge, but there would still be a small gap that wasn't kind of obvious, but the cotton pad would have picked it up, but that wasn't being used in that way. So I guess in short, what it means is that in the 2014 edition, the cotton pad is used for longer. And so it can now identify those small areas that do ignite the cotton pad, and therefore the failure time for integrity will be lower in some instances under this 2014 version of the standard. And so it looks like fire door manufacturers became aware of this, they had a problem, and so Firebolts resolved that issue, if you like, by closing the door into the frame.
Right. So this slight tweak in the wording of the standards meant that it was harder for these fire doors to pass the test. So the fire bolts were introduced as a way of passing the test that the doors would have previously passed without needing them. That's really interesting. Thank you so much, Aaron, for that sort of detailed description. I'll come back to you for some questions a little bit later on. I know a lot of people on this call will already know that, past year or so, we've had a number of the state's fire and rescue services coming out with various position descriptions and documents around the use of these fire bolts within our buildings and our built environments. This is an example of Fire and Rescue New South Wales' most recent statement. They actually updated this in December last year, having released their first one in April. I'm sorry if the text, it's quite small on your screen and probably a bit difficult to read, but it is available on their website. And it basically raises or highlights their concerns about the doors being inoperable during a fire, that the bolts may activate too early, so the doors can't be used by occupants to evacuate and will hinder the fire brigade to do their, when they're doing their job. So we're joined by Chief Superintendent Stephen Hayes, who is here and can tell us a little bit more about Fire and Rescue New South Wales statement and what your main concerns are when it comes to these fire bolts. Thank you, Stephen.
Yeah, thanks, Fiona. Well, Fire and Rescue have made some comment over the last couple of years with regards to the implementation of heat-activated fire bolts within doors. And it mainly stems from once they're activated, the fire services have no ability to enter the building without the use of mechanical force, and therefore the occupants of the building have no ability to safely exit the building. It can also happen if a door has been left open and the heat travels into the open area of an apartment block. And as we all know, and as was stated by the previous presenter, that the fire bolts are put into the top of the doors because the top of the doors are the part of the door that warps the most. I'd say the more lightweight construction that we've done to actually get firebolt or get doors to be lighter and pass the test with the implementation of fire bolts, that would render all the other sole occupancies in the building unable to move out of their occupancy due to the top of the door and the activation of the bolt. Now, so we've noticed this in buildings over the past couple of years. So we went through and along with other fire services, as you say, have put out a position statement where we acknowledge the fact that these bolts are being used to maintain stability and integrity of the door structure within the test regime. However, I suppose for easiness of the test, you heat the door uniformly across the door, and then the bolts activate in a uniformly manner, and the door becomes, for all purposes, part of a wall. Well, most fires aren't like that. Most fires start with a heat layer at the top of the building, so that would say that the occupants in that room, the door bolt could go off, as we found in the last presenter, at an unknown temperature. So whether they're 270 degrees to 500 degrees, that position could render somebody inside that unit still in a tenable atmosphere to exit the building, but with no possible means of exit because the door bolts have gone off. So Fire and Rescue did put out an initial statement back, I think it was April, where we just mentioned fire door bolts and the activation of those. However, subsequent meetings and advice from our engineering side had said, you know what, we don't really support anything that doesn't supply the requirements of the NCC and the EPNA regulation across the door for the rated period of time that the door is in the door set, that we might have to get access. And I suppose from my position as a firefighter, I've had 35 years in this service. I've unfortunately been to 7 incinerations, as well as removal of infants from buildings and subsequent medical procedures on the footpath to keep them alive. The added time that it would take us to make entry and remove persons from buildings with fire-bolted doors isn't something that we need or they need at the time of their need. So that's why the stand Fire and Rescue have taken. And as far as intricate questions about engineering, I've seen some of the ones, Fiona, and our stand is to keep the 9,000 firefighters that Fire and Rescue employ in New South Wales safe and able to do their job, and to keep the hundreds of thousands of people that live in sole occupancies and other unit-based living arrangements safe in their building, and have the opportunity for us to intervene at a time when we need to.
Thanks for that, Stephen. I think that's really important to bear in mind when we discuss this, is that the real world implications this has. These firebolts came about to help these doors pass the fire test, and actually not to help in a real fire situation. So thank you for sharing that with us. And
I think the real thought pattern here, and I know engineers have a job to do and such, but do we sacrifice the lightweight? I'm cheapness. I don't mean by cheapness, but do we sacrifice that for the workings of a door and the safety that it provides and the access and egress that it provides to those persons inside the building and outside trying to get in?
Yeah. I mean, that is one argument, isn't it? That could we just make these doors a little bit stronger, a little bit more robust? But obviously, there's a cost implication to that. I think we've already mentioned there's a weight and a force to open the door. So there are other aspects to consider as well. So thanks again, Stephen. I'm actually going to bring in Simon now from FPA Australia. Now, the FPA has members from all avenues of the fire industry. You have members that are fire door manufacturers, door suppliers, installers, as well as fire engineers, and you're all grappling with this kind of curveball of these fire bolts. Can you give us a little bit of a brief overview of what are some of the biggest concerns you're hearing from your members? Oh, you're still on mute there, Simon.
It's not my first rodeo either, to be honest. Look, firstly, thank you for the opportunity today. I really appreciate that. Look, what our members, they are, as you said, they're grappling with the situation. They're looking for certainty. Obviously, our members, they sit across the entire spectrum of this conversation, and it's imperative that greater understanding can come from these discussions, and in turn lead to greater clarity. I think if the right conversations can be had, it will certainly assist our members in understanding a way forward. And I generally believe today's webinar is probably the start of these conversations, and that in earnest, and hopefully it's the first of many. It'll certainly support our members significantly. So we've got our technical advisory committee, TAC 1819. I know they've been dealing with this for a number of years, and we're hoping to have some meaningful discussions within that TAC in the very near future, and then to have the wider industry join in those conversations. And for what those conversations look like, we're 100% supportive of a consultative approach moving forward. So thank you.
Yeah, and I think you've hit the nail on the head there. It's that certainty, kind of almost either way, isn't it? That we're after today. We're not expecting to solve all the issues in today's webinar, but starting these conversations is that first step. So yes,
I'm glad you've instigated that this afternoon, and hopefully, without stealing a word from earlier, but hopefully it ignites the conversation now. So
yes, well, hence the title of these webinars, and really bringing the industry together for these important discussions. So thank you, Simon, and really appreciate that there is so much uncertainty amongst a lot of people in the industry at the moment. Indeed. So I'm actually going to jump now to Stephen Kipp, who's going to help perhaps shed some light on some of the sort of the various issues with the thoughts and also the things that have come out of the various position statements. So Stephen, I'm going to hand over to you now.
Thank you, Fiona, and thank you to IFE and FPA for the opportunity to speak today on this really interesting topic. So having read the 3 brigade statements, to me the common themes are compliance with the deemed to satisfy provisions in AS 1905 and 1530 Part 4, which Aaron just covered. And the issue that's really, again, I should say at the start, building codes are always chasing technology and innovation. They're always behind, because when regulations were written, the idea that you would have a firebolt in a door was just not what was considered. So the second bullet point there about whether fire-rated door sets should remain operational throughout a building fire is really the nub of what we're here to talk about today, and I'll touch on that as we move forward. But then the last issue is whether the use of firebolts, which is really the next step and in an increasing level of door restriction. So intermittent seals were the previous technological move forward, if you like, so that the idea that a door stops being a door and becomes part of the wall in that critical phase is really what requires the door to jam itself shut in that context. And again, I'll touch on that in a moment. So just coming back to the building code issues, it's a performance-based code. I think most of the audience would know that. You can satisfy it 2 ways: by a deemed to satisfy provision or a performance solution, product-specific or building-specific. We're talking here about whether fire safety engineering performance solutions are necessary for firebolts. We'll get to that, but hopefully that's clear to everybody. This is the bit that matters for this session. So deemed to satisfy provisions are deliberately drafted because there is potential for a deemed to satisfy provision to not satisfy the relevant performance requirements. The lawyers call a deeming provision a legal fiction. So I've worked on legislation where cattle was deemed to be sheep for the purposes of legislation or vice versa. Probably the best example is that the building code would theoretically allow, under deemed to satisfy, for an intensive care unit or an operating theatre to have openable windows. So the idea that you would actually have windows open during an operation is, of course, ludicrous. And the step up from that is that the other option is mechanical ventilation systems, which almost every engineer everywhere, or hopefully every mechanical engineer would specify for an operating theatre. So that highlights the role of building codes as a minimum standard as opposed to best practice or acceptable engineering standards. So in terms of those 3 issues, if an existing fire door set has a valid test certificate as prescribed in the test standard in the NCC, then it legally complies with the NCC. So that should be reassuring to building owners, certifiers and builders, and certainly the legal cases that support particularly builders and certifiers being able to use as a defence compliance with the deemed to satisfy provisions of the BCA is well known and well established. The NCC is also the minimum standard, and what that does is creates a duty of care for some practitioners. In this case, it's going to be fire engineers for sure, architects potentially, to understand where a deemed to satisfy provision is not sufficient. And again, I gave that example of the openable window in an operating theatre. And where a deemed to satisfy provision is not sufficient, then professionals have a duty of care to consider and recommend additional or alternate measures. Now, if the owner says, thank you for your advice, I don't want to do it, then you've satisfied your duty of care because the owner can fall back to the minimum requirements. And of course, the 3 fire brigade documents form part of that duty of care consideration and resolution process. And I want to say at this point, that's why I think the 3 fire brigade documents have been so helpful to trigger this discussion, because really this is that area where without a disaster, we would not have the ability to have this discussion. So again, I think those documents have been really helpful to formulate a deeper understanding of what is a probably not well documented part of the building code. So again, I'm going to talk about the building code because it doesn't really cover firebolts, to help people understand where we're going to. So the 3 documents talk about C1, P2 and D1, P2 and suggest that exits need to remain operational throughout a fire event and not impede fire brigade intervention. Now, this is where I started thinking about this and really getting a bit twisted, like most of us have, I think, or a bit confused. The fire event is really at least 3 phases. And if you think about a fire door in the 3 phases, you've got the evacuation phase where the door clearly has to be a door. Then you have the flashover phase where the door ceases to be a door and becomes an important part of a fire-rated element, wall usually. And it could be a firewall, but it could also be a sole occupancy unit boundary wall, which is not a firewall. And that at that point, it's one of the weak links in the firewall. So it's really, really important that that door, which has now become part of the fire barrier, works well. And this is where Aaron talked about gaps and warping, and Stephen talked about some of the challenges for firefighters. Those small gaps allow smoke through, and as they get larger, allow flame through. They can be a really significant weak link in the overall fire safety of that building if they fail. Then you've got the post-flashover phase, which is where the fire brigade documents are suggesting we should at least think about whether the door stops being a barrier and becomes a door again. And that's the bit that's challenging for most of us to get our heads around, particularly if you've seen some fire door testing, because it's a really difficult practical consideration for a door. So again, just to stir the discussion up, in my opinion, C1, P2 actually has no wording that supports the view in the policy documents, because actually that's about spread of fire, and the better a fire door holds itself in place during the flashover phase of a fire, the better it achieves compliance with C1, P2. But D1, P2 definitely does talk about egress and doors. But again, in my view, reading the words and acknowledging they were written before this issue came up, so I'm not suggesting that words written before an issue can ever trump the actual issue. But in terms of the words as they currently stand today, occupants and firefighters within the building code are separate groups. There are different requirements for occupants versus firefighters. And that performance requirement talks about all doors. It doesn't just talk about fire doors. So there's an even broader discussion that if D1, P2 relates to every door in a building, whether it's fire tested or not, and that they need to remain operational for anything more than the occupant evacuation phase, then that is a significant issue that warrants a lot more discussion, analysis, and perhaps evidence and review. Again, consistent with the material properties of doors, because they're timber, because, for example, 30 or 40 years ago, we banned asbestos, and the Corps are now using safer materials that are perhaps not as good in terms of fire safety, then we've got this problem of expansion, burning, twisting, warping, deformation. And that means to require all doors to be operable in the end phase of a fire, post-flashover, would, in my view, be disproportional to the risk or the evidence as it stands today. But I'm not saying it's not a real issue, but it would be a very significant change to the building code. So the last question then is the use of firebolts a problem? Well, I've spent some time over the last few weeks trying to understand this in more detail. Almost all fire doors are difficult or impossible to open after a standard fire test. That's partly due to the fact that you've got very tight gap requirements around the door, that the door will fail at the hinge and the latch set. And you'll see in the video at the end of this presentation some examples of hinge failure. So the screws aren't very long, for example. The hinges are metal. They're not designed for the temperatures we're talking about. The latch sets can be even sometimes alloys. Intumescent seals have been used for decades. They typically sit either into the edge of the timber door or behind the timber edge, so that when the door is heated, they blow the door out to fit into the frame as tightly as possible and effectively wedge the door in the frame. And it's doing that for logical reasons, because smoke spread is a significant issue that we're trying to manage. And then, of course, fire spread. Again, as Aaron touched on, for wider or taller doors, the warping and cupping effect can overpower or misalign the intumescent seals, and a firebolt will be used to lock the door. So if you can imagine, as the door's twisting, it's opening up gaps, and the intumescent seals can't resist the twisting because their role is only across the seal in one dimension. From speaking to some fire testing colleagues, it seems the problem is greater for higher fire ratings, and that would make sense because the exposure temperatures get much higher. And certainly many, if not most, -6030 doors will not need firebolts. So that's reassuring based on what Stephen Hayes' advice was, because sole occupancy unit doors to apartments only have to ever be 60 minutes. And that, you know, the number of times a -12030 door will be used is much less. Again, I've said there the BCA rarely requires -12030 doors. I know lots of you are going to say that, well, what about doors in firewalls? Firewalls are walls used to break a building into fire compartments, and those doors are typically in egress corridors. And yes, they are required to be -12030, but they'll always be the minority of doors in a building because, for example, you can't use more than half of the doors as exit doors as a horizontal exit. Reassuringly, also, I've seen some research that CSIRO have done and other people that firebolts and intumescent seals both seem to activate at least 200 degrees Celsius, but firebolts particularly could achieve an activation temperature of 350 degrees for perhaps very little increase in cost. Again, Aaron talked about that little plastic grommet at the end. That plastic grommet is the bit that melts and releases the bolt. And again, it might be that the solution is to codify that, or at least in the early phases, as Simon suggested, maybe a code of conduct or code of practice for fire doors in the short term, to make it clear that the fire bolts themselves are being tested at the activation temperature matters. Here's some photos that I've added. So again, just to wrap up what Aaron and Stephen talked about, you can see these fire door tests are failing exactly at that point where the fire bolts go. This is the top and the side hinge. But you can also see how much damage has occurred to that latch set. So there's a very low probability that that door handle will actually still turn and open the latch after a fire test. And again, if you look at the picture on the right-hand side there, that's a double door set at about the point of failure. All of the edges are on fire now. So you can see there the point at which a door becomes a barrier is the really important part if there's a flashover fire on the other side. But again, then if the door needs to open after that phase, it would be very difficult with current door technology to make that work for all practical purposes.
I think you had one more slide there, Stephen.
Thank you, Fiona. So I think to sum up all those discussions, fire doors are a critical weak link in passive fire protection, and the ability of the door to resist fire and smoke spread should not be compromised. So that's the starting position. Intumescent seals and fire bolts are there for good reason. They're there to resist the spread of smoke and fire longer and better. And actually, a lesser rated door would achieve the firefighter requirements better, but potentially would create a problem for fire spread. So it's like every fire safety system, there's always a compromise. What is the lesser evil that we need to operate here? But certainly advice for fire engineers in the current situation is that make sure you don't over-specify fire doors beyond the minimum requirement in the building code, because it might be that creates an accidental problem. Again, the lower the FRL the door, the easier it will be to operate after a fire, because it will be more damaged, but it will spread more fire and smoke in that phase of doing its job. Look, most of these doors from the video we've just seen are possible to be opened with a mechanical device, a crowbar, axe or hammer or whatever, and with some force, and should be possible to be opened. Again, that's a discussion that Stephen Hayes talked about. Maybe we do need to limit the number of fire bolts so that that's not possible, because it might be that manufacturers could change the doors by adding more fire bolts and less robustness to the door itself. And in the short term, just for discussion again, make sure that you don't over-specify a fire-rated door, but perhaps increasing the activation and limitations on fire bolts would be a worthy thing to do in the short term. Thank you, Fiona.
Okay, thank you. Thank you, Stephen, for that detailed description there of some of the issues, surrounding these fire bolts. And definitely, it's not a clear-cut issue with a clear solution. I was going to bring back Chief Superintendent Stephen Hayes, and whether Stephen, you had any additional comments around any of the issues that Stephen Kipp brought up, or any further comment around any of that?
There was just a few. The doors are tested so that they satisfy the burn and, in my terms, the warpage of the door. But then how do you classify that they've passed the other two hierarchies of the test with regard to being certified as fire-rated fire doors? Because the way I see it, and this is just my personal opinion, they only pass one part of the hierarchy, not the other two. So they still don't have the ability to be opened after the fire, and they still don't satisfy, as you say, the P. What is it, the D1 P2? So you've had a certified door that's certified, but only from one part of the actual test.
So, Steve, I'm not sure I understand. What are the other two levels of the hierarchy? Do you mean the performance requirements?
Yeah, they still must provide. They still must be operable after the fire and provide access and egress. So the door, once it's fire bolted into the frame, doesn't supply any of that. So there's still the ability, or there's still the problem that the door bolts activate at whatever temperature. They're not regulated. So I could be in my unit, I have a small fire, the door bolt's activated through the heat layer at the top of the door. I'm unable to get out. Fire brigade are unable to get in without, and the use of mechanical force just isn't an easy thing where you take an axe up and you chop a hole in the door. That just doesn't happen in anybody's world. There's hydraulics that need to be used. There's the setting up of that. There's the actual intervention that we have to do, which takes time, which then does not give us that extra time to effect a proper rescue of that person in the building. So as far as the testing by CSIRO, whoever does the tests, they've done your fire test, strapped it to a frame, heated it up uniformly across that frame, the door bolts have activated, but then the other two parts of the requirement of the NCC and the EPA regulation, they still don't satisfy because they don't supply those upper hierarchies of the test.
I'm not sure how to respond to that, Stephen. So the deemed to satisfy provisions are the law. It's a bit like a speed limit, if you like. So if you're driving down the freeway doing 100 kilometres an hour with a blood alcohol content of 0.049%, having not slept for 3 days in a car that's barely roadworthy, you comply with the law, but you might not be considered driving safely. So in terms of compliance, the fire doors comply.
No, they comply to the pad test. So they don't have an opening where heat and flame comes out through the opening. However, the D1P2 that satisfied that the doors must ensure they remain readily operable by a person seeking egress or access, they don't comply to that because they're now a wall. They're not a door. So for all purposes, there is no door there anymore. So it might be more or sort of, it might be easier for a fire service to break through the wall than it is to break through the steel frame door set. So whether it's speeding in a 60k zone or whatever, it still doesn't satisfy another part of the regulations and the Act or the NCC to supply the whole gamut of what the door should supply. So it maintains integrity during the fire, but it still must maintain the ability for fire service intervention or occupant exit. So it doesn't do that. So it doesn't pass all of it. So how is it certified?
Well,
I think they're really important questions, and I think this is what today's session is about. And I think what Stephen Kipp was trying to get at, that actually currently our doors aren't tested to remain operable for the duration of the fire. That if we are going to start doing that, further investigation, further discussion is needed about that. I think one of the crucial things you picked up there, Stephen Hayes, about when these fire bolts are activating is a crucial part of the picture. Now, I believe some work is going into creating a standardized test for these fire bolts. That's not yet to be released, but maybe that is part of the picture, to have some satisfaction that the temperature that these fire bolts activate at is going to mean that the temperature on the fire side is untenable anyway, so no one's going to be sort of surviving that door. And like Stephen Kipp said, maybe that's increasing it to 350 or something like that. But at the moment, there isn't a test for these fire bolts, which is probably one of the concerns for myself. And what's the longevity of these fire bolts? If you're installing these in fire doors, we know what fire doors look like after 10 years. And that little plastic grommet at the end there, is that still going to be activated at the same temperature? Is it going to be able to function in the same way it was intended for the lifespan of these doors? So
we can look at the Bankstown fire, Fiona, for some actual evidence on what can happen in a building set. When you have one fire door that's wedged open, the unit catches a light, that heat then transfers into the open lobby. So if you look at the coronial photos for the Bankstown fire, you'll notice that in the hallway, all the door sets in the common way are all affected at the top of the door. So that if they were fire bolted doors, we wouldn't have got access into that common way to actually fight the fire for the first point. And secondly, those people wouldn't have evacuated out, because that common way was to the temperature where your door bolts would activate, but still tenable in the sole occupancy units.
Yeah. Very, very interesting points there. I'm going to slightly change the track, because I am conscious of the time, and we've had, as I said, many questions come through, and already I'm seeing lots on the Q&A as well. But I'm going to pick out a few that came through as part of the registration. And Aaron, I'm going to actually go back to you on this one. And the question was around, should fire engineers be producing performance solutions where fire bolts are present or proposed? As a fire engineer, what are your thoughts on that one?
So my personal opinion is no, I don't think we need to. I don't think that it should be incumbent upon fire engineers to resolve the firebolt issue. If the industry as a whole is rejecting firebolts, and I'm not sure we're quite there yet, but there's obviously some pressure, then that's not an issue for fire engineers to necessarily overcome in all situations. Having said that, I do think there will be situations. I've worked on some buildings recently where every level has access to more than one escape route, and it was sprinklered, and it was sub 25 meters, and there was no sleeping, and all of these things which mean that we sleep safe at night, knowing that we're not worrying about this building. I would have been comfortable with those doors having firebolts. That's not to say that I would still write a performance solution for that. I don't think it's incumbent upon fire engineers. It's incumbent upon the fire door manufacturers to resolve this issue, either by using data to demonstrate that these things don't fail and removing the arguments that come up, or by removing firebolts and building a better door that passes the test without the need for them. I think both of those can be achieved.
And maybe bringing some sort of fire risk assessment into the picture. So you say, maybe where there's a secondary means of escape, they can be used, but perhaps we're not going to be using them for where there's vulnerable people, for example, that may need additional assistance to evacuate, or longer evacuation times, like places with phased evacuations. But is that bringing too much complexity into the issue? All right. I'm going to actually go back to Stephen Kipp now. And I think you did touch on this question very slightly. But one of the things that keeps coming up amongst my discussions is what happens if these firebolts are banned? What will the impact be on our existing building stock? And will it be a little bit like the cladding crisis? And will building owners be required to replace any of the fire doors with firebolts in them?
Wow, that's about 5 questions in one, Fiona. So well
I did combine quite a few questions that came through.
Just coming back to what Aaron was saying, I think the law matters. In fact, I know the law matters. The law is the law. It doesn't mean it's right, but it's a starting position for all practitioners and for everyone else. So at a very simple level, at the moment, tested fire doors with a test certificate are deemed to satisfy compliant. So you cannot do a performance solution for them, but an engineer has an obligation to do a hazards analysis under the Australian Fire Engineering Guidelines and should always consider all of those issues. It's actually very similar to the battery issue now. I'm saying lithium-ion batteries, but batteries generally are being added into buildings for all sorts of purposes, sometimes static, sometimes fixed, sometimes movable in cars. And there's nothing in the building code about that at the moment that deals with fire safety, but fire engineers can't ignore it. But you also can't do a performance solution to justify why the code is compliant, because the code is actually silent on it. Mm-hmm. So I think that's a really important legal difference. Yeah. And that's why it's different to the cladding crisis. So the cladding crisis was all about non-compliant construction. And this issue at the moment is currently about compliant construction not being sufficient. And that's a completely different issue. So
And when we update our standards to change that compliance requirement, it doesn't backdate it. So anything that was previously installed, am I right, Stephen, will remain okay in the eyes of the law?
Well, governments can retrospectively legislate for laws to go backwards in time. It's just they're very, very rare. So if you have a house that's 50 years old, it was not required to have a smoke alarm in it, but you should have one in it now. So if the issue is significant enough, with enough evidence, governments could regulate it. But I think we're a long, long way for there being enough evidence to retrofit fire doors from the last 3 or 4 decades. Not saying it won't happen, but, for example, we don't retrofit buildings to more stringent requirements in the hydrant code or the hose reel code or any other of the codes. We just say that as new work occurs, you would upgrade to those standards. Mm-hmm. So I think the dilemma we have is that Stephen Hayes' points are really valid, and really I'm trying to make the point that we should always listen to what the fire brigades say about operational firefighting challenges, because we don't know. Yeah. But at the moment, we lack enough evidence to certainly have a retrospective law for this. I think we have enough evidence to modify the laws from today going forward, and then to monitor the evidence about going backwards. Yeah. Stephen Hayes wants to add something, I think, at that point.
I know. Just our thing is we've seen fire bolted doors right down into SOUs, with a fire rating of 60. So it's something that the industry's picked up and run with and started to install them in all different types of scenarios. That's the issue that the fire service come up with. Aaron.
So I was saying this the other day to some of the panelists, that Stephen Kipp said earlier that we'll see these on higher FRLs, and we'll also see them on wider and taller door sets, because because they're impacted more and they open up these gaps. We had them on a project for a -60/30 door, so not a high FRL. The doors were a standard height, but they were 1050 wide. So 1050 is not particularly wide. We're not talking about a 1.2 meter wide door here, or slightly over a standard door width. And initially they required firebolts. The firebolts were fitted. Fortunately, to avoid a big issue, the doors were being retested and they passed the -60/30. And so we were able to take off the firebolts. And I believe there are kits now where you can remove the firebolt, fill the hole that you've made for the firebolt, and then that re-achieves, if you like, the FRL with the firebolt removed. But that was just retesting that was done. I still think if you
and only good if the door passes as is.
But let's be clear though, Aaron. So the problem, that sounds fantastic, but the problem is, was the solution to increase the intumescent seals, for example? Is the door still unopenable after a fire, but we now we haven't solved the problem, we've just kicked the problem down the road? Because you can beef up the other things. The reason a fire door works so well is because it jams itself in the frame. That's the challenge here. If we say that doors can't do that and they have to be able to be openable, then I'm not sure what the solution looks like, but taking the firebolts out doesn't solve that, because the intumescent seals have the same effect and actually have potentially a much lower activation temperature.
But from the novice, what issues were we having with fire doors prior? Well, what issues were buildings having with failure of fire doors and fire spread prior to the introduction of bolts to jam them into the door frame? Is there any evidence to say that our fire doors weren't operating or failing or providing greater fire spread? So why did we actually move to a need for fire bolts? And don't get me wrong, anything other than trying to produce a cheaper, more lightweight door, and we can stop deflection with fire bolts, so that we can achieve the passing of a test with a cheaper, lighter door.
Yeah, it's a really good question, Stephen. And I'm 100% with you on this. If manufacturers are using this technology to save cost and that existing doors work okay, then we should go back to that position. No question about that. But I first became aware of this issue in 2010 after the Black Saturday bushfires, because people were selling private bushfire shelters with fire-rated doors on them and thought a 4-hour door was better than a 1-hour door. But of course, that would entomb occupants in a private bushfire shelter. And I worked on the committee that drafted the guidelines for that. So fire-rated doors that are used in commercial buildings were essentially banned from private bushfire shelters for that reason, because they jam into the frame. And we had some public seminars, and a couple of manufacturers who were selling shelters got up and left the room. They were so horrified by it because they thought a higher fire rating was safer. So this is partly about communicating the problem, understanding the problem, and then communicating what the best solution is. And it's always going to be a compromise, because we've got timber fire doors because we don't want the cost of using stainless steel coated doors everywhere. So we have some practical economic considerations, but timber warps, twists, and cups in fire. Timber, these doors are literally on fire in the test. Now, we can make doors that aren't on fire, and we can do all sorts of things. I've worked on development of doors for private bushfire shelters, and they're stainless steel wrapped with calcium silicate cores, with latch handles made of calcium silicate or some carbon fiber or whatever's necessary to stop temperature rise across the door. You can do it, but you drive the cost of the door up by an order of magnitude, and building codes are trying to be the minimum standard, not best practice. Now, again, I don't think there's any disagreement between us, Stephen, other than on whether minimum standard is sufficient today. And I'm conceding 100% that we have to do this analysis to work out what the problem is. But there is very little evidence that it's a serious problem yet. And again, I understand the concern of the fire brigades that that's not good enough to wait for a serious problem. But maybe some extra testing would solve this issue, Fiona.
Maybe. And actually that leads to my next question. And this discussion is great, by the way. We have hardly had any of the questions from the audience yet. But what is the next step? How do we get to a resolution? What can we do as an industry together to find a way out of this situation?
I think that there's a disconnect in the reading of the performance requirements between engineers, and I won't put words in your mouth, Stephen, but I think Stephen Kipp might sit on this side, and the brigade in terms of, and it's not just for doors, but in terms of any system. I don't know that the performance requirements expect a system to be impacted by a major fire and still be operational without any repair or upgrade post-fire. So it's not just a fire bolts in fire doors issue, but any system that we have in a building is going to be impacted by a fire, emergency lighting, exit signage, sprinklers, detection systems, fire doors. And I'm not sure that there should be an expectation beyond that. I'm not sure that's how I read the performance requirements, as they should operate afterwards as well. It's kind of done what it's there for at that point, and then once the fire's out, which is obviously where your concerns come in, that you're in there during the fire or after, immediately after or before, then we can repair and make good and fix everything, because the walls, the doors, the cables, everything will need repair.
I think one thing probably that's lost on this as well is the fire services do use doors for fire control. Like we do need door access and the use of a doorway for fire control on an internal firing units. This is why our issue with sole occupancy units and the lower temperatures of bolt operation, because we do use firefighting techniques in those situations that require the door to operate. So we smash the door open, we don't have what we call fire control of the unit, so the fire exits the unit. So we actually use that door, open the door, apply water, shut the door, wait, open the door, apply water, and that is one firefighting technique that's widely used in the world, even in high areas of high insulation coefficient. So that's one of the only ways you can control some of these fires. So it is important that the door operates during the fire so that we can maintain some sort of control if we need to.
And I'm going to come in there with you as well, Stephen, because some of the questions in the chat are about this, and what if these fire bolts activate while the door is open? Then no one's going to be able to close the door and create that seal and use the door, as you have described there. But the current standards for testing these doors don't include a firefighter trying to open and close them and squirt a hose through it during the test. So it's a very difficult.
And that again, Fiona, that same problem is worse with intumescent seals. If an open fire door is exposed to 200 or 300 or 400 degrees, the seals will operate, the door won't close. In terms of where this might head, Stephen, it would be helpful for me. So D1P2 talks about all doors, and about half of the fire deaths occur in Australia in bedrooms, in apartments or houses, and the door to the bedroom is never a fire-rated door, or hardly ever. We'd probably say never for all practical purposes, but that door surely that door doesn't need to satisfy D1P2 and be openable after a fire, even though that's likely where someone will have been subject to some very significant fire conditions. So it might be that the performance requirement needs a footnote that says this only applies to fire-rated door sets or something, because surely it's not every other door. Like balcony doors could be open for ventilation or could be used for egress, and they're not tested for fire rating at all. So is it just the fire door issue, Stephen?
Yeah, so I suppose to put this into some context, one job I went to, I'll just say old mate was asleep on his bed, his unit was alight, he stood up to put his undies on, and going into the heat layer, he died before he got his hands past his ankles, and he was dead on the floor with his hands on his ankles and his jocks. So the atmosphere was still tenable on his bed. So that means that person, if they crawled out to the door, for all purposes, would have stayed alive till they got to the door and maybe made entry or exit through the door. But the heat layer was that intense above shoulder height that when he stood up, that was him, and I mean instantly done. So that's the fire service's concern, that if that happens in a sole occupancy unit or anything like that, and that top bolt goes off, or that person is stuck in that unit, yes, they can get out onto the balcony. I agree with that, but there's still, if everything else is shut up, there still has to be an avenue for them to escape, because there is instances where they happen.
But there is nothing in the building code that says a bedroom door in an apartment flashover fire has to open.
No, but what I'm trying to point out is that tenability in a unit can still be maintained on the floor, where at shoulder height it's over the temperature for tenability. So if your doors or the doors that are in sole occupancies with fire bolts in the top corners are subject to the same heat as in old mate's unit, well, they've already gone off. He stood up into it. He's dead instantly on the ground. But if he had have kept his mind and crawled out to the door, he could have got exit through the door. That's the only thing. The testing is a uniform heating, and I understand how they do it. But there's no anything between real life and the testing of a door is just that the door's in a door frame.
So one of those conflicts between engineers and architects. I love the idea of a full height door and wide as possible in my apartment, but I hate the fire safety concept of it, because it's just a really difficult space because of exactly what Stephen's talking about, that temperature lamination layers that come down from the top to the bottom. But we lose that fight every time, don't we, Aaron?
One of the questions actually was around, why are we going for these larger, higher, wider doors? And maybe we need to invite, our architect colleagues to these sort of sessions as well, the ones that are making these design decisions.
Isn't it so you can get your big fridge in?
I was going to say, and your television and everything else.
Yes. All right, I am very conscious we're already 8 minutes over time, so I am going to start winding up there now. I'm sorry we didn't get through all of these amazing questions in the Q&A section, but hopefully we'll continue some of these discussions on LinkedIn afterwards. So as we conclude this valuable session, I would like to extend my heartfelt thanks to the FPA for inviting the IFE to co-host today's session. Your support and collaboration has been instrumental in making this event a success. A special thank you goes to our sponsor, Zurich Resilience Solutions, and your generous sponsorship has played a crucial role in bringing us all together today. I also want to express my deepest gratitude for our esteemed panelists. Your insights, expertise, contribution, and these real-world examples have been truly enlightening and have made this session possible. And finally, I would like to thank our wonderful audience. Your participation and questions you've sent in advance have greatly enriched our discussion. Your engagement and interest are what drive us to continue these important discussions. The IFE strives to be the nexus between the fire service and the rest of the fire safety community. And I think today's session exemplifies what we can achieve together. When this session ends, please do take the time to answer the questions that will appear on your screen. I'm particularly interested in your suggestions on what other subjects you'd like to hear about as part of this IFE Ignite webinar series. And do jump on to LinkedIn, follow our IFE Australia account and connect with myself as well. And we will continue this discussion. Thank you all for joining us today, and we look forward to seeing you all at future events.